Hello, my dear class 7 children. Today we will complete our chapter 4, light energy. So let's begin. So children, come to page number 53, regular and diffused reflection. We know that light reflects of all opaque objects. How the light is reflected depends on the nature of the surface of the object, that is, from which it is reflecting. If parallel rays of light traveling through a medium is incident on a smooth surface such as a plane mirror or still water, it is reflected according to the laws of reflection. Since every light ray is reflected perfectly from the same surface and bounces back in a regular way, the reflected image is very sharp and clear. This kind of image is called regular reflection. As you can see, the parallel beams of light rays, when they are striking, when they are incident on the surface, after reflection, all the rays of lights goes back in a same direction such that they are also parallel to each other. That is, all the reflected rays are parallel to one another and all the incident rays were also parallel to one another, and they follow the laws of reflection. This kind of reflection takes place from highly polished metals, mirrors and still waters. They are known as regular reflections. Images are formed as a result of regular reflection. Regular reflection also causes glare. Now let's move on to diffused reflection. When the surface is not smooth, the parallel rays incident on the rough surface strike at different angles and get reflected in many different directions, satisfying the laws of reflections. As a result, reflected rays get scattered. Such reflection is called diffuse reflection, as you can see in 4.5a. No image will be formed, but it is this diffused reflection that makes non-luminous object visible to our eyes. As you can see, 4.5b, the diffused reflection from the flower to our eyes enables us to see it. Thus, we see most of the things around us due to diffused reflection. Diffused reflection cuts glare. Next, we have plane mirror. One more thing, children, the diagrams of regular reflection and diffused reflection are very important. Now let's move on to plane mirror. Any opaque surface, rough or smooth, is able to reflect light. Regular reflections from a smooth polished surface, example mirror, give rise to an image. Now let's see the definition. A flat, smooth, straight piece of glass that is silvered at its back surface is called a plane mirror. Now for plane mirror, there are two types of image formation. As you can see, image formation by a point object and image formation by a large object. What you will do, children, you will draw the image formation by a point object, that is figure 4.6a in your physics classwork copy. That is all that is required from plane mirror. Now let's move on to the characteristics of images formed by a plane mirror. They are as follows. The image formed by a plane mirror is always erect. Erect means it is upright. Next, image is formed behind the mirror and is of the same size as the object. In case of a plane mirror, whatever the size of the object is, the size of the image will also be same. As you can see in figure 4.7, the boy standing is the object and the image formed is the image of the boy. Both are of the same size. Next, the distance of the object from the mirror is equal to the distance of the image from the mirror. This all of you have seen. If you are standing in front of a mirror, the distance, your distance from the mirror is same as the image formed on behind the mirror. Next, the image formed by a plane mirror is laterally inverted. What is the meaning of lateral inversion? The right hand side of the object appears as the left hand side of the image and vice versa. Children, if you stand in front of a mirror now and check, your right hand will appear as the left hand of the image and your left hand will appear as the right hand of the image. This is known as lateral inversion. You can also check the lateral inversion of letters. Suppose if I write A, B, C, D, anything like this, the letters have lateral inversion. That is, the left appears as right and the right appears as left in the image of the object formed by a plane mirror. This phenomena is known as lateral inversion. In a plane mirror, the rays of light do not actually meet at eye. What is eye? Eye is the point where the image is being formed. We extend the rays to meet at eye, so it looks like the rays are diverging from eye and the image is formed behind the mirror. That is why we are not able to get an image on the screen. The image that cannot be obtained on a screen is called virtual image. Remember children, there are two types of images. The image that can be caught on a screen is known as real image. As you can see, the image that can be obtained on a screen is called a real image. Whereas the image that cannot be obtained on a screen is called a virtual image. Difference between real and virtual image is given in this chart. Real image can be obtained on a screen, virtual cannot be obtained on a screen. Real image is always inverted, virtual image is always erect. Real image, the rays actually meet at a point after reflection. In virtual images, the rays appear to meet at a point after reflection. Image is formed in front of the mirror, the image is formed behind the mirror. So these are the differences that you need to learn. This is a very important difference. Next, you are having the uses of a plane mirror. Plane mirror have a number of uses. Number one, at home in beauty parlors and barber shops to make small shops seem larger than they are. In making periscopes, solar cookers and toys such as kaleidoscope. In measuring instruments to avoid error while taking readings. These are some uses of plane mirror. Learn at least 3 uses. Children, next we are having the speed of light. The speed of light in air or vacuum is 3 into 10 to the power 8 meter per second. To the power 8 means after 1 there will be 8 zeros. And if you multiply that with 3, that much meter per second, in per second light can travel that much meter through air or vacuum. Speed of light varies when it travels in transparent medium like glass or water. Speed of light in water is little bit less, 2.25 into 10 to the power 8 meter per second, and in glass it is 2 into 10 to the power 8 meter per second. Principle of least time is not required for you for this class 7. You will learn about this when you go to your higher classes. So now let's move on to primary colors. Primary colors. Sunlight, which can also be called white light or simply light, consists of light of 7 significant colors and their shades. This already you all know. It is having the acronym VIBGYOR: violet, indigo, blue, green, yellow, orange, red. Now, light of any 3 colors that produce white light when combined with the correct intensity are called primary colors of light. They are lights of red, blue and green. Almost all visible colors can be obtained by addition of lights of these 3 colors in different proportions. Children, don't mix this up with the colors which you use for coloring anything. This is the light colors that we are talking about. The sunlight which is coming from the sun is a combination of these 7 lights, which when separated can be seen as a rainbow where the 7 colors are seen. Now out of those 7 colors, the 3 colors that can produce white light, they are known as the primary colors. They are red, blue and green color. So almost all visible colors, whatever other colors that you can see around you, can be obtained by the addition of the lights of these 3 colors in different proportions. Proportions means quantity. Now formation of secondary colors by color addition. This is very important, children. Please note it nicely. A color resulting from the mixing of lights of 2 primary colors is called a secondary color. The process by which lights of different colors combine to produce lights of different colors is called color addition. So these are the 2 definitions. Secondary color is a color resulting from mixing of lights of 2 primary colors, and color addition is this process. As you can see here, some colors are given. Red plus blue gives magenta, blue plus green gives cyan, red plus green gives yellow. So cyan, magenta and yellow are secondary colors formed by the color addition of lights of different primary colors. If lights of red, green and blue color are projected on a screen, and when they all overlap, white light is produced. This is often represented as red plus green plus blue is equals to W. As you can see the combination in this figure 4.11, red plus green. As you can see this little spot, it became yellow because this is a mixture of red and green. Red plus blue, as you see in between the small spot, it became magenta. And blue plus green, in between that spot, it became cyan. And combination of all these 3 circles is this center spot, which is white. So red, green and blue gives white color. Children, appearance of the color of an object and color subtraction are not included in your half-yearly syllabus. So my dear children, this ends our half-yearly syllabus. Hope you have understood this chapter. Please go through the topics that I have taught. I will provide with the notes in the next class. Till then, stay safe at home. Take care, children. Thank you, class.